Welcome back. Today we're going to be starting the unit on statistics. Today we're going to start that unit by talking about scatter plots. So let's go ahead and take a look at a few vocabulary terms. So here are some things to keep in mind as we're talking about scatter plots. Remember, scatter plots show us a trend. The data in a scatter plot must be quantitative. This means the values must be numbers. Scatter plots show us patterns to help us make predictions about what could happen, and scatter plots do not show us causality. That means we cannot determine what exactly for sure will happen based on a scatter plot. All we can say is how likely or unlikely something is based on a trend. Now let's take a look at correlation. Here we are looking at correlation, and there are four types of correlation that we're going to talk about. Correlation describes the relationship between two variables. So the first correlation we're going to talk about is positive correlation. That states as time spent studying increases, a student's grade increases. So positive correlation as this one thing increases, the other thing increases. Then we have negative correlation, and that's where the one thing increases and the other thing decreases. That doesn't necessarily mean that it's going to be bad. And negative correlation does not mean something negative is happening. For example here, as time spent training increases, the time on the 100-meter run decreases. So that's a positive thing. That person is getting faster at running, but that has a negative correlation. The more you train, so training increases, the faster you can run, so your time decreases. The next correlation is a constant correlation. As the number of people increases, the cost is constant. So for example, in this case, we're talking about the cost of parking at the Verizon Center. The number of people in cars does not affect the price of the parking. It's going to be the same whether you have 3 people in the car or 5 people in the car or 7 people in the car. The parking is going to remain the same. So that's a constant correlation. And then, of course, there is a no correlation or none. There is no relationship between test scores and shoe size that we see here on our graph. Now that we've talked about correlation, let's talk about the line of best fit. So here we're talking about the line of best fit. And it says this scatter plot shows the price of menu items as chez Henri's compared to the average price of times that the item is ordered each night. So how many items are on our menu? To do that, we simply just count the number of X's there are, the number of dots, however many things are shown on the graph. That will tell us how many items are on the menu. So if we count all of our X's up here, we should get 15. So there are 15 items on our graph. What type of correlation do we see here? So we see the points, they're going towards a downward trend here. Sure, we have a couple that are over here to the side. We'll talk about what those are later. But for now, we can say that in general, our correlation of this graph is negative. So if a data shows a general trend, which we can see here as it's going downward, we can use a line of best fit to the trend. This shows us the correlation between two sets of data. So we can see here that this line, as we're going to put it right between most of the X's, doesn't have to be exact for now. All we're trying to do is get most of the X's in the middle, some on top, some on the bottom. That's our line of best fit. We can use this to help us make predictions about the data. So now let's see a couple of those predictions in practice. So in predictions, this says the scatter plot shows the amount of gas used on different car trips. Use the line of best fit to make predictions. So the first question says, predict how much gas will be needed if they drive 220 miles. So if I go over here to my graph and I go over to 220 miles and I'm going to go up towards the line of best fit. A common mistake people will make is if they see a dot right where they want it to be, that's the answer they will give. But that is not using the line of best fit. That just happens to be how that car did driving that amount of distance. But on average, or what we can predict based on our trend, is using the line of best fit. So we want to use the line of best fit as our answer. And when we do that, we should get 7 gallons. So along the lines of best fit is where we select our answer, not just happen to be where a dot is. The next question says, predict how many miles can be driven on 5 gallons of gas. So again, we're going to go up to our 5 gallons on our y-axis here. We're going to go across, and again, we're not going to stop when we see any dots. We're going to stop when we hit the line of best fit, and the line of best fit is around 150 miles. So that's going to be our answer for that one. So again, we're going to use the line of best fit to make predictions, not based on whatever dot that we happen to see. Now let's take a look at outliers. So here we're talking about outliers on scatter plots. An outlier is a data point that does not follow the general trend. So it's things that are going to stick out from the trend that we see. So for example, when we're talking about our graph about Chez Henri, we can see that we have two data points here that are outliers. So even though they're really expensive, they're being ordered lots of times. And there are always reasons for outliers. Perhaps those are the things that are the best dishes that this restaurant serves. So they are very popular and people order them even though they are very expensive. The other graph that we have there is monthly gas use, and we can see the outlier here is down and to the left. The general trend shows a negative trend, but there's one all the way over there to the left. And of course, there could be a reason for this. Why did they use less gallons of gas to heat their house? Maybe they were not in town. Maybe they spent time at their summer home. So there are always reasons for outliers, and that's why we generally use a trend to answer our questions and make predictions. We don't depend on one use case that is an outlier. Now let's take a look at example A. So here in example A, we're going to be given a bunch of questions about our scatter plot, and we're going to use what we know now to answer these questions. So the scatter plot shows a relationship between Josh's age and the time it took him to run a mile. So what is the correlation of this graph? So we can see that we have a general trend as something is increasing, that would be his age, that his time running a mile is decreasing. And we're going to call this a negative correlation. So as Josh's age increases, his time in the mile decreases. For how many years did Josh track this information? So all we're going to do is count our dots there, 1, 2, 3, 4, 5, 6, 7. So he tracked this information for 7 years. So Josh wants to predict his mile time for age 25. Should he use this graph? Why or why not? Because we can see the graph stops at 18 years. So the question is, can he still use this type of trend for when he gets older? And the answer is yes. As he gets older and stronger, his time will continue to decrease. Of course, at a certain point, his time will level off, and this will become a constant correlation because you can only decrease your mile time so fast depending on training, if he stops training, etc., etc. But if he continues to train, then obviously as he gets older, bigger, stronger, his time will decrease. Now let's take a look at example B. So here we have Nick and his hockey practices and the goals he scored. So each week, Nick tracked the number of days he went to hockey practice and the goals he scored. So we're going to answer the questions that we have based on the graph that we're given. So how many weeks did Nick measure this info? So we're going to count the number of dots that we have there, 1, 2, 3, 4, 5, 6, 7, 8, 9. So he tracked this information for 9 weeks. What was the total number of goals scored? So again, we're going to add up all of the goals scored there. So for example, the 2 at the bottom, he scored 0 goals. So 0 plus 0 plus 5 plus 2 plus 2 plus 3, 1. When we add them all up, we're going to end up with 19 goals. What is the median number of practices that Nick attended? So again, in order to remember, or hopefully we remember how to find the median, but if we do not, in order to find the median, we need to line the numbers up from least to greatest. Okay, they have to be in order from least to greatest in order for this to work. So the least amount of practices that he attended was 2. The most amount of practices that he attended was 9. Then we're going to cross them off, heading from each side. So we're going to cross off a 2, a 7, a 6, a 3, a 6, a 3, a 5, a 4, and we land with the 5 right in the middle. So that is our median. He's attended a median of 5 practices. What is the mean number of goals that Nick scored? So in order to figure out the mean or the average, we're going to take the total number of goals that he scored, that's 19, divide by the number of weeks he went to practice, that's 9, and we find that he scored around 2.1 repeating goals per week. So around 2 goals per week or 2.1 goals per week. So what point is our outlier? Remember, that's the thing that's not going to follow the general trend. And we can see it up there on the graph, way up high is right there. And we're going to say that the outlier in this case is scoring 5 goals only after 3 practices. So again, we can answer these questions based on the data that we have. That brings us to the end of this video. So if you've liked this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.